Hello, good morning, good afternoon, good evening. So today we will go through complex number. Okay, complex number is also one of my favorite topic to talk about. Okay, so I believe that you guys should already have some knowledge about complex number. So yeah, I'm just gonna give you extra nuggets to make you organize your thoughts, consolidate everything. Yeah. Okay. So to me, right, the main thing about complex number that is that there is three form. Okay. You have your um, Cartesian form, and then you have your trigo form, and you have your exponential form. Okay. So yeah, why do we need to learn all these three? Okay, that is the purpose of everything. Okay, most of the time when you are dealing with this kind of addition or subtraction of a number of complex number, okay, it's best that you use this. Does it make sense? 5 plus I 4i and 3 plus 5i. Okay, then if you plus you use, okay, compared to, okay, if you compare these two scenario, right? If you add them out, okay, the first one will give you 8 plus 9i. So why is this good? Is because it is in the Cartesian form of polar of complex number. Sorry. Okay. So whenever you present an answer, you need to present it back in one of these three form. Okay. That's why when you are doing multiplication, it's best that you use the Cartesian form. Okay, whereas for this, right, you wouldn't be able to express it in this manner. Okay, that's why when doing addition, right, use Cartesian. Okay, so when do you use exponential? Okay, you use exponential, right, when it is a multiple or division kind of questions. Okay, so in this scenario, right, it will become 6e I 5 plus 3, 8 over 15 I. Okay, so this is Cartesian form. Sorry, this is exponential form. Okay, so it is one of the expression of complex number. So can. Okay, this one cannot. Okay, so Cartesian is for addition and subtraction. Exponential is for multiplication and division. Then what is trigo form for? Okay, trigo form, right, is for you to transit um from exponential to Cartesian. Okay, so for example, you have this, right? Okay, they want you to express in terms of Cartesian form, right? Then you go to here, so you 6 cosine 8 pi over 5 over 15 plus I sine pi over 15. Okay, you start doing this, then you will get this. Okay, calculate it out. Okay, the exact number of this cosine and sine. Okay, so that is it. There you go. Okay, so do note that, right, let's say your equation is, for example, bracket cosine, say I over 4, okay, minus I sine I over 4. Okay, do note that this is not a one of the form of complex number. Okay, you need to change it to this way. So like you need to force a plus here. Okay, because this is the format. Okay, so in order for this to be a plus, this have to be I sine bracket negative pi over 4, and here will be, so this and this to be in this form. Okay, your theta need to be the same. Okay, so over here, right, you need to be minus pi over 4, and um, coincidentally or luckily, okay, your cosine negative pi over 4 is equals to pi over 4. Why? Think of the graph. Okay, sine negative pi over 4 equals to negative sine pi over 4. Why? Think of the graph. Okay. Yeah, so I believe I already covered it during the last chapter, which is vectors. So yeah, I shouldn't cover too much on it for this chapter. Okay, so you already know question that is involving question that involve addition and subtraction, how to do. Question that involve multiplication and division, how to do. Okay, now how about question that involve addition and division? Okay, how to do? Okay, so over here, right, for example, this is pretty common. Say, can be anything. Pi, say, okay, let's do some weird number. Okay, 4 pi over 7. Okay, minus 1 over then maybe 2 pi over 8, 2 pi over 9. Okay, so like this kind of scenario, right, there is a addition, subtraction. There is a subtraction and there's a division. Okay, so now become what you're gonna do, right? Okay, so you can do it this way, but it will be pretty tedious to change this one, right, into Cartesian form first. You think change this to Cartesian form, then after that, minus 1, right? Okay, so here okay, let's see. E to the power of Okay, so you're gonna get this negative 0.225 etc. 然后 plus 0.9749i. Okay, then after that, this one minus this one, then you get a new a plus ib. Okay, then so this cannot be, it's not conducive to divide by this. Okay, then after that you might want to change back to, okay, the exponential form. After that, solve. Okay, so yeah, this is a bit tedious. Okay, so I believe that some of you have came across this kind of question. Okay, pi over 2 kind. Okay, which is more straightforward lah. Okay, so in this kind of question, right, okay, you will do, Okay, so why you do this, right, is that this and this is related. How are they related? Is z minus z conjugate. Okay, so when you are doing with minus, think from the Cartesian perspective, that means that it will produce two imaginary of z. Okay, so this will be equals to ei pi over 4, then two imaginary of z, so 2 times then I. Okay, so 2i sine pi over 4 because imaginary of z. Okay, not z conjugate. Okay, then after that here divide by ei pi over 4. Okay, so calculate, then you will get sine pi over 4 equals to square root 2 over 2, so square root 2 over 2, so it's square 2i. Okay, so like is it just applicable to like this kind of scenario, or is there like a way to do it for any kind of scenario, which is something like this? Okay, so this is the something that I just thought about it, or it come to a realization recently lah. Okay, so think about it now. If we see the um if we take a closer look at the angle, okay, this is their angle. Okay, so we have an angle of 4 pi over 7 and 0. Okay, so to make it into the z minus z conjugate form, right? Okay, the angle need to be the negative of each other. Okay, that means to say, right, you need to shift this whole thing, right, okay, by half of this amount in order for them to be negative of each other. Okay, so 7 divided by 4, then minus half of it, 2 divided by 4, 4 divided by 7 minus 2 divided by 7 equals to 2 divided by 7. Okay, so 2 divided by 7, and over here is negative 2 over 7. So you can see that the distance between them is 4 over 7 and 4 over 7 for both cases. Okay, so like you need to kind of create a shift to change this ei 4 pi over 7 and ei 0, right, into something that is like this, where the angle of this and this is the same, is the negative for each other. Okay, so here we will write 2 pi over 7. Here we will write negative 2 pi over 7. And to balance the equation, it will be ei 2 pi over 7. Okay, as a result, okay, so I'm gonna write in this direction now. So yeah, please bear with me. So here ei 2 pi over 7 and 2i sine 2 pi over 7. Here is 2 over 9, 2 pi over 9. Okay, divided by ei 2 pi over 9 equals to 2 divided by 7 minus 2 divided by 9 and 1 ei 4 pi over 63, then 2i sine 2 pi over 7. Okay, if they ask you to write, give in exact, okay, and in this form, REI theta form, okay, note that why is there an I here? There shouldn't be an I. This R is a real number. Okay, so this I we need to handle it. How do we handle it? Anyway, any idea? It cannot be dissolved inside here. Okay, so the best way is to do some manipulation between these two because I is ultimately a complex number. So now we have complex number times complex number. Complex number times complex number using exponential form, definitely you can make it into a new complex number. Okay, so here will be 2 sine 2 pi over 7, which is your real part, okay, which is your r, and ei 4 pi over 63. Think about your Argand diagram, okay, your I is here, so it should be pi over 4. Okay, so this is your I. Okay, so it equals to 2 sine 2 pi over 4 and ei 4 over 63 plus 1 over 4. Okay, 1. Okay, so it's 79 over 2 pi 2 pi. Okay, so this is the other things that I want to share with you guys lah. Okay, other than that, all the other properties of the conjugate, etc., right? Yeah, that one, yeah, try to understand it based on the your what I told you. Okay, if it's divide is what, if it is yeah, minus, then is use Cartesian, etc. Divide means use exponential to reason it. Okay, so don't have to memorize all those stuff. Okay, the only thing that you need to memorize, right, is which don't really need okay, but then just bear in mind that sometimes yeah, these will be asked as well. Okay, so yeah, that one I don't really have a direct method to explain. Yeah, so usually this kind I would go and memorize before my exam. Actually, there is okay. So think about it, all these in terms of real and imaginary lah. Okay, so so here there's a negative bi ma. Okay, here is a plus bi ma. Okay, so after everything you conjugate, right, everything will be in terms of negative, right? So the in terms of y, okay, so it should be like that. Okay, while all the a should remain as positive as itself lah. Okay, so that's why you apply the conjugate to both of these. Okay, so it will be like this. Okay, so I believe that is most of the properties. Then yeah, it's a pretty straightforward chapters skipping all the fundamental basic introduction. Yeah. Okay, so that's all my thoughts for complex number. See you in the next one. Bye bye.